you tired of watching hours of confusing videos by guitar music theory experts on YouTube and still not understanding a darn thing they're on about? Then you need the Songwriting Inspiration app. For only $5, you can organize 6,000 guitar chords into relative major and minor keys and get tons of fresh new ideas for more sophisticated chord progressions and songs. Downloading Song is like downloading music theory straight into your brain. Link is in the description. Hello, what is up, ladies and germs? Brad the Guitarologist here, and in this video I've got quite the treat for everybody. This is a 1953, I believe, Fender wide panel tweed twin amp. We're going to check this thing out. We're going to go through the history of the twin amp and the twins in general and kind of set this thing on the timeline as far as Fender amps go. But first we will take a look at the general condition of this. You can see that, you know, while this does have the original tweed, it has been completely worn off in places, including up here on this top panel. We do still have the Fender logo there with the Fullerton, California on there. But once again, you can see the tweed is completely gone in this upper area. This is one of the taller Fender amps that they made, and I think this is actually the tallest one they made around this time, so it's kind of hard to see the top with my current setup, but you can kind of get an idea what I'm talking about. We've got areas where the tweed is just kind of, you know, worn off, fallen off. I mean, it's an old amp, man. It's from 1953. It's been well loved, well worn, well played. We're gonna dig into this thing momentarily, but first I want to get into a little bit of the history of the Fender twin amp. The Fender twin amp was first introduced at the 1952 NAMM show. It was generically called the High Fidelity Amplifier. The twin amp name would come later. With two 12-inch speakers and 25 watts, thanks to the push-pull 6L6 power section, it was the largest and most powerful Fender amp to date. It also featured some Fender firsts, such as the first amp with two 12s, and also the first amp with separate treble and bass controls. The twin amp also had the highest tube count to date in a Fender at 7. Coming at the tail end of the TV front era, which had begun in the late 40s, it was also among the first of the new wide panel tweed amps, having wide tweed covered wood panels at the top and bottom only, rather than on all sides of the front grille. The earliest known schematic for the twin amp is labeled 5C8. The naming convention for Fender amp circuits in the tweed and early brownface era was as follows. The first number stands for the decade, in this case it's 5 for the 1950s. The letter stood for the generation or iteration of the amp model, with each succeeding letter representing a change to the circuit, such as a change from octal to miniature 9-pin tubes, for example. The last number stood for the amp model. 1 was a champ, 2 was a Princeton, 3 was a deluxe, and so on. The name twin has survived on Fender amps in one form or another to the present day, and collector-grade examples of the 1950s tweed versions are among the most expensive amps money can buy. While 5C8 is the earliest known schematic for the twin amp, there is evidence, which we will cover in this video, suggesting an even earlier, scarcely documented version of the circuit existed. Our example may be one of those. But with lots of work having been done to this amp over the years, it's unclear whether a full factory circuit restoration will be possible with the information we have. Okay, we're back with this 1953 Fender twin amp. I've removed the upper panel, and you can see that it's been pretty much totally serviced by someone at some point. Now, I don't know to what level this has been serviced, but just from what I can tell, it all looks pretty good. It looks like they've used a lot of decent capacitors. The orange drops are pretty good. It does look like most of the original resistors are still left in place. This one looks original. This one looks original here. This one is questionable and probably not original. Some of the ones with a little bit of a brighter appearance, I think, are probably not original just because they sort of stand out. This one, probably that one as well. Yeah, just a couple of these, they don't quite look the part and may have been replaced at some point. That one right tucked down in there might have been replaced as well. Not that it's really that big of a deal to me, or, you know, I don't think the owner is really that concerned about it either. And I'll just tell you this, you know, this is not really in here for our traditional service per se. This is in here so that we can take a look at it, so that we can go through it, make sure everything is in working order. The owner is just, you know, he's just wanting to ensure that everything is as it should be. I already see one thing I'll probably change. That depth capacitor right there is in place and doesn't need to be. I'm not sure why they would replace the depth cap. Doesn't make a whole lot of sense. But they've got a 3-prong cord in here, and you can see the grounding for the 3-prong cord over there. Inside the cabinet down here, you can see, first of all, we've got speakers that appear to be the original speakers. They are 220, which is Jensen, 3, which is 1953, 07, 7th week of 1953, and these are C12 PS, and I believe these are probably original. If not original, they're definitely Jensen's from the correct year, because these have got the big bell housings on the back, and they have a 3 code, so they're 1953 for sure. I can't tell you for certain whether these had C12 PS in them, but I think these probably are original speakers. We do have a tag down here, and that looks like it's the original one and not some kind of replacement, and it does say twin amp 0095 on the serial number over there, handwritten. And you can see right there that super amp is marked out, and twin amp is stamped on the tube chart. You can also see that 6SC7 is stamped over there on the tube chart out to the right of the third 6SC7 in the chain. So yeah, they basically just took this super amp tag and converted it to a twin amp. Now the twin wasn't always even named the twin. I think it was named originally something else. But you can see here the tube complement, 5U4G, a couple of 6L6Gs. Those are the Coke bottle versions of the 6L6. Of course, this is early. This is 1953, so that's about what you'd expect. The 6SC7 complement, those are octal tubes, all in the preamp, and there's 4 of those. A little bit later now, you would have come along and had 12 AX7s in the preamp. Would have come a couple years later, I think, with the newer version of this amp. But you can see, like I said, it's been pretty well serviced, so this is going to be one of those situations where we're kind of just going through it and making sure that the service was done right. Everything looks good. You know, voltages all look good. We don't see anything that's that needs to be replaced. I do see a couple of those resistors right in here. These are in the power section. Those are dropping resistors in the power section, and they probably measure okay, would be my guess, but and they look like they've been replaced as well when this thing was serviced. But the thing is, you know, really for this thing to run right and to be tip-top, I would probably want those to be some kind of metal resistors instead of the carbon resistors that we see in there now. But something more like these would be more appropriate for the power sections. You see how these are changed anyway. And the thing is, you know, obviously this is not a 100% original example or anything like that, but the thing is, it's a player example, and it's one that obviously has been serviced pretty extensively, and I'm sure probably works just fine. We got the tubes inside of these wrappings, so we will unwrap the tubes, we'll get the tubes installed, and we'll fire it up and just dial it up slowly on the Variac, take some measurements, and just make sure everything comes up properly. But essentially, that's what we want to do. We just want to check everything, check voltages at each node, make sure those are okay, check the voltages on these 6SC7s and make sure those are all okay and that everything's functioning properly. So yeah, and also we'll test each one of these capacitors, the coupling caps, and make sure that, you know, none of these are leaky. Obviously they've been replaced, so they probably are not, but we're just to be safe, we will test them all. And yeah, just basically give it a general checkup. Here's a little better look at the top, and something you may have already noticed is that the handle is obviously not original. This is a later addition, and it's not, you know, it's not the appropriate style, but the appropriate style would be a leather handle that probably would be a little bit too weak to carry an amp this heavy anyway, so I don't see much reason to replace it unless you're just really into the cosmetic and you just want it to look you know, 100% correct. You can see as far as the inputs, we have 2 microphone inputs, 2 instrument inputs. We have a microphone volume, number 1. We have instrument volume. We have treble. We have bass. We have our nice little twin amp logo over here. If we can get it to not be blown out. Let me see it. There we go. Fender Electric Instrument Company, Fullerton, California. Got a standby switch, on-off switch, jewel light, fuse holder. We'll go ahead and check the fuse, make sure that it's looking appropriate. Fuse is a 2 amp slow blow fuse, which appears it's probably appropriate for this amp. I haven't checked the schematic quite yet, but it's probably right. So yeah, let's get the tubes in this thing now and check it out. Okay, as for the tubes that were sent along with this thing, we have a mix of tubes, of older tubes and newer tubes. We've got a RCA 5U4. We've got a couple of JJ606 GCs. These are not the 606Gs. So that's going to make the amp capable of a little bit more output probably than the original Coke bottles. We've got a tongue sole 6SC7, and if that one is good and not microphonic or otherwise weak, that would be a good tube, good candidate probably for V1. This GE is also older. This is a 6SN7 though. I'm not sure why I've been sent an SN7. But there it is. We've got an SN7 here instead of an SC. We have an SC7 here that's a Sovtech, and we have another one that's a Sovtech here. So the 6SN7, we'll see what we want to do with that.
It is fortunate for the community that I am not a criminal.
Okay, so here's where a bit of detective work begins. If you'll recall down here on the tube chart, we have 4 6SC7s listed. On this schematic at least, we have a 6J5 in this position. So that already conflicts with what we have on the tube chart. Now we know the tube chart was something that was a holdover from another model anyway, so we want to, of course, compare this with what we see in the amp. And if we look at this closely, the 6J5, we'll see we've got pin 1 going directly to ground. You can see over here we have 8 and 1 tied together on all these. So we have pin 8, pin 1 are tied together and going to ground. The only exception is on the J5 here where we have pin 1 and 2 tied together going to ground. And again over here we have 8 and 1 going to ground. Now if we look at what's in the amp, actually we do not have pin 8 and pin 1 tied together going to ground. Same thing right there. They're not tied together or going to ground. Here we have them tied together going to ground. And here we have them tied together going to ground. So, and those are also original. If you look at the soldering on that, that's original soldering. You can just tell by the general patina and age of that solder job that is probably 100% original on that. It's original on that as well. This one's not original. This has been added. And you can see where some solder is here, which would have been about the same distance as it would have been there. So originally this would have been tied there. So this would have been also a 6 SC7. We already know that this is a 6 SC7, and this is the position that this one calls for a 6J5. So I think maybe what we have here is an early variation of the twin amp. I'm going to have to see if there's a schematic that exists, that will reflect what this should have been originally. But I can tell already that this thing has been modified from its original version. So we're going to try to probably restore this. I'll get in touch with the customer who owns this and see what he wants to do with it. This is owned by Tom Colvin, who is the owner of the speaker workshop up northern Indiana. But yeah, definitely. And you can see here as well, we've got a blob of solder right here, which is about the same distance as it would have taken to get to this tube. So this socket's been modified. This one's been modified. The SN is a medium gain triode, a dual triode tube. The SN is a medium gain. And it's got, you can see here, okay, the grid is on pin 1, whereas on the SC, if we look at it, it is it's this socket, it's an 8S socket. So on pin 1, it's a shield. That's why you see it tied to ground. And these are not tied to ground. So I'm assuming they probably meant that whoever modified this probably meant to modify it with two 6SN7s in these first two positions. I'm guessing probably to try to keep the amp cleaner. So if it's not 100% original, you're going to have some detective work to do to make sure everything is, you know, the way it should be. Now we do have a lot of wiring over here as well that looks like it's been shrink tubed. You can see this has all been shrink tubed. This is all shrink tubed. Now that could have been a case of just the wire, the old wire was just deteriorating and they just put tubing over it, over some new wire, because they looks like they used this red wire and they didn't want it to stand out maybe too much. If you're going to own an amp like this, you know, it would tend to make sense that you would want the higher gain tubes in there just so you could get more breakup. But then again, you know, maybe that's not his bag. I need to really speak to him and make sure, again, what his hopes are for this amp and how he wants it to turn out, because if he wants it to be more original, we're going to have to do some rewiring most likely. So stand by on that. We'll see what we need to do. Okay, so I think I might have figured out why Leo Fender may have changed the design of this amplifier after using the 6SC7 on this initial first few. Because the 6SC7, if we look here in the RCA manual, 6SC7 is a high mu twin triode. That means it's a higher gain. Usually anything that's high mu is has an amplification factor of 70 or above, and sure enough, over here, if we look at amplification factor, which is what this column is, we get a kind of amplification factor is 70 for that tube, the 6SC7. It's also got some other differences. If we go to the 6J5, though, however, that's a medium mu triode. It's not high gain. So if we look over here, the amplification factor is actually, I believe that's the right column, yeah, is actually 20. Plus, in addition to the fact that this is a single triode, whereas the SC7, like I've said, is a dual triode. So there's two amplifiers in the same envelope. So, you know, like a 12AX7, it has dual triodes. This is most likely evidence of Leo Fender's attempts to keep amplifiers clean. As we've discussed a lot on this channel in the past, Leo Fender, he was really all about cleans, and he, as you know, Fender wore on, he was constantly finding ways to clean up the amplifiers. He probably would have hated the sound that, you know, all the guitarists got out of the 59 Bassman. That's not at all what that amp was designed for instance. You know, it wasn't he didn't design it for it to be overdriven to the point of distortion. You know, he would have been appalled by that. And the entire Tweed line of amplifiers from the early 50s all the way up to the end of those around 1960, you know, he designed those really based around a lot of older designs that had come from the all the way at the beginning of amplification in the 20s. You know, those are all based on older designs. But as time wore on and he got into the brown face and then especially the blackface era, you know, he really figured out a lot of ways to keep the amplifiers clean all the way up the dial. And, you know, in the blackface era, I think he really kind of perfected the clean sound. And that's, you know, the sound that we often associate with the Fender sound is the blackface era sound. But anyway, I digress. Bottom line is the 6J5 is a medium mu triode with an amplification of 20, whereas the SC7 has an amplification factor of 70 and is a high mu triode. So this definitely would have changed the character of the amp in some measure. It probably would not. it would have cleaned it up quite a bit to move to the 6J5. But we're going to move it back to the 6SC7. And what I think we're going to do while we're at it, while we're moving it back to the 6SC7, we're going to come in here and again, we'll have to do some investigation and see, you know, exactly what this would have been, and try to make some educated guesses as to how it would have been wired just based on evidence that we see. So we need to put these back to stock. This one, however, looks like it might be fully stock already. And what's interesting is it is wired, I believe, in parallel, because we see right here pin 1, okay, pin 2 here, 3 and 4. So pin 2 is a plate. So the plates are bridged together, and also the grids 3 and 4 are bridged together. This thing is already being run in parallel. Okay, so we got a heater going to ground. We also have the shield going to ground. Now, in later versions of the 6SC7, like the GT, pin 1 is no connection, you can see there, so it doesn't go to any kind of shield for that. So it really doesn't matter, but let's see what the cathodes are doing here. So we've got both the cathodes are tied together anyway internally, so that's going to pin 6, and let's see, pin 6 on this one is here, so that's going to there, and we do see a big capacitor there, and what is probably a bias resistor there. So this is already wired for 6SC, and so is this one. This is also wired in parallel, just as we suspected it might be. So this is going to be, I would have to guess, that this is going to be an even more desirable version of the Fender Twin Amp than even the 5C8. This might even be preferable if you're into, you know, overdriving your tweed Fenders, which a lot of people are. This might give you more of what we associate with a tweed type of sound even than the 5C8. So this is going to be interesting. Let's go ahead and rewire these sockets to accept the 6SC7, and then we'll move forward from there. Okay, so there we are with all of the caps installed. As you can see, it at least looks a hell of a lot better. More consistent look. So if somebody opens this up and they take a look at it, you know, if he ever has a prospective buyer looking at this thing, wanting to buy it, you know, he'll have the impression that, you know, somebody cared enough to use top quality components and did a good job overall. I removed the death capacitor as well, replaced those dropping resistors in the power supply, and yeah, it's just looking a lot better. I've also cleaned the controls, and let's see what else. I need to clean the sockets, and we'll rewire these sockets, and then we should be about ready to dial it up on a Variac. If you guys mess with many older amps, especially this cloth wire, I know now this one might be as well, but usually this is this stuff is cloth, but it has a layer of asbestos in it as well. So you don't want to cut a bunch of this stuff up and just leave the trimmings kind of just laying around everywhere, because that white shit, I don't know if you can see it, but in a lot of this cloth wire, that white shit in there is asbestos. Okay, so those should be rewired now. That was easy enough. So I believe at this point, this thing is now back to factory stock. So that's with 4 6 SC7s. The V3 tube is wired in parallel, and it's pushing through the tone stack in parallel. So I believe that's correct. Now I got to check the pots because a couple of these pots have been changed. And you know, pretty much like everything else in this thing, we have had some changed pots. I think maybe all of the pots have been changed. That one's from 1973. See right there, 137. That's CTS. 73 is 1973. The 40th week of 1973 on this 1 meg pot. Is that correct? That's a correct value. This one is an alpha 1 meg, and that is also a correct value. This one, kind of hard to tell if it's original or not, but it looks like it's 1 meg, and it is correct. This one should be a 2 meg. This one should be a 2 meg, the bass, and it is right there, B2 meg. This is an alpha pot. So every one of these pots I think has been changed with the possible exception of this one. That one might be original. I'm not sure on that one, but the other 3 have been changed. Now all we have to do is clean the sockets, clean the input jacks, the output jacks, and then I think we are ready to dial up on the Variac. But yeah, definitely looking a hell of a lot better, that's for sure. Oh, I also forgot to mention, I did come through and I checked every single resistor in the amp, and all of them are within tolerance, so we're good there. This should be like basically like a brand new amp. We're back to stock on the tube, so it should be really interesting to hear what this sounds like, and honestly, it should be just about as close as you can possibly get to an original 1953 Fender twin amp. Okay, so if we'll recall, these are the tubes that we had. There was one that doesn't match anything. We also had a pair of JJ tubes for the output tubes. Those were 6L6 GCs. I'm going to replace those. What I think I might do, those 6L6s look, those GCs, they look pretty darn new. So what I might do is give him credit for those, and trade him out for some decent old 5881s or something like that to put in this thing. But we'll at least test it with the JJs preliminarily here. But I think tomorrow I want to go back to my other house. I want to grab a piece of wire to replace that one wire. And I also want to grab either a nice old set of Coke bottle 6L6s or a nice old set of 5881s from the 50s that would have been something that might have come in this originally. Yeah, let's just give it a go. I did have a little bit of a problem a moment ago when I tried to fire it up, and I found out I'd miswired something. I'd put one end of one of the capacitors in the wrong spot, so I fixed that real quickly, and let's fire it up now. It's gonna be a lot of overdrive with this thing, man. I'm only on 85 volts right there. And let's go ahead and check our voltages at our first node here as well, while we're at it. That's at 288 volts at the moment. We're at 99 volts on the input, and we're looking pretty good there. I'm a little bit concerned because well, I don't know, maybe not. Maybe not. We're drawing about 70 watts overall, which might be 80 watts now, which might be a touch high for an amplifier that only has two 6L6s. But the current's okay. We're below 1 amp on the current. We're at 0.8 amps on that. 350 volts on the first node. The bass control isn't doing a whole lot. But then again, there's not a lot of bass content in the generator signal, so there's a little bit of hum in the background that I don't quite care for, and it could be tube related possibly. All right, it's staying. I pulled V1 and the hum is still there. Let's go down the line. I'm just curious. I think it sounds to me like it's going to be filament related. Turn off the now obviously we're not shielded or anything either, but that's some of the noise right there. That lamp is introducing some noise. But the low hum though, whoa. That right there? Look at that. See that? All I'm doing right there is grabbing this tube, look. Now why would that be? Unless we might have a bad tube. I think that might be a bad tube right there. See, look. I'm grounding now. I think that's a microphonic tube or something right there. Something's not right with that one for sure. I'm gonna try something else here. Let's move our microphonic tube to the end of the chain. We'll make it the phase inverter for now. But see, listen how microphonic that is. Still getting a lot of noise there. This position has got a lot of noise. No matter what. It's whatever, something to do with this position. Maybe that's why he changed it, because that's that third position. Okay, so this is the position that the J5 would have been in, and that's the one that's making all that racket. So I know it's socket related because I just moved tubes. See? Now I can get that noise to kind of stay. Yeah, that's weird. Okay, I think I want to kill it. And I think I might also experiment with removing that bypass capacitor on the cathode. So let's remove that 220 microfarad bypass capacitor on that cathode right there. Can you even hear that? Here, let me put it down here by the speaker. Let me put the... You hear all that wailing going on there? I've had experiences in the past where howling like this has come from stuff like bypass capacitors, but I couldn't say for sure, and that could be a bad ground too. Right there, that could have something to do with it. Let's flow some solder and do some measurements. I actually want to check. I want to check the measurement from this point right here to ground, because if that's not a good ground, that could cause problems like that. I also want to probably pull that capacitor from the circuit completely and just see if that fixes it too. Let's hear that. And it doesn't seem to be dependent on the tube. So like I said, here I'll show you again. Okay, so let's pull the tube. Okay, so all the noise disappears there, pretty much, except for a little bit of hum, which we would expect. Now I'm going to take this brand new tube, so I know this one should be good. Well, I mean, you know, you say that, but that's the expectation at least. It could also be a manufacturing defect with this type of 6SC7 too. I don't know. Well, there's no howl there right now. My God. It's noisy as hell though. Alright, let's try the instrument channel with the guitar, just for giggles for a second. There is a lot of hum. There is a lot of hum. So we've got some kind of grounding issue here. Something's going on. You know, I don't know if it could still be tube related, but I don't know. Now we know, let me get the microphone back up here so you can actually hear me. We do know that they did, again, they changed the power transformer on this amplifier at some point, and that could possibly have something to do with why it's humming so bad. I mean, that bass too is just, that's feeding a lot of noise in. So I need to explore that, figure out why there's so much noise. Probably now that 220 microfarad capacitor had been changed to a 50 by someone before me. I want to test those components around this socket and just make sure that everything's copacetic with that. But we've got some hum. There might be a problem with also a center tap issue on the filaments. We might check and see if the filament winding has a center tap on it, and if it does not, we may have to try to add a virtual center tap to quiet this thing down, because this is really, I don't know, man. It's really a lot louder than I would expect. But then again, it's following the volume control. So whatever it is being introduced in the preamp. So that might not be the case after all. And I suspect that it's somewhere around this socket. Okay, so here is that capacitor I was talking about, that 220 microfarad. Now the schematic calls for a 250 microfarad, but that is the schematic that has the wrong tube in it. So that's, you know, the 5C8 schematic that has the 6J5 tube in this position. So when it calls for 250 microfarad, that might be just fine for the 6J5 that's running just one single triode. But we have here, like we said, we have a high mu tube that is running two triodes in parallel. So probably this might even be too much. So what I had done is I had gone back to the schematic for the 5C8 on this value. When the previous tech who had serviced this, he had a 50 microfarad capacitor in this spot. So I'm thinking possibly here, one of two things happened. Either from the factory, this version of the amplifier, this early version, had a 50 microfarad capacitor in that spot, or the alternative is the tech who serviced this put that 50 microfarad capacitor in there because it sounded better and it lowered the noise.
Give me the most abstruse cryptogram, the most intricate analysis, and I'm in my proper atmosphere.
I'm guessing probably the case is that this was a 50 microfarad from the factory. Just the fact that none of the other values were changed. So it's not like the person came in here and started messing around with a bunch of different values. I think it was just a fact of them coming in here and changing out like value for like value throughout the amp, and they just basically service the amp without changing very much, except for rewiring these first two tube sockets. Now, what, you know, if they rewire these first two sockets, I could understand them fiddling with some values here, but they didn't rewire this socket. So that tells me that they may not have fiddled with this value at all. So it might need to go back to a 50 microfarad. So let me try that. We'll go ahead and yank that out of there. Actually, I think before I yank it completely out, I think I might just try it without it, period. Still a little bit noisy, but nothing like it was. I mean, if you grab it, it's going to be noisy anyway, because again, we've got two triodes, high gain triodes in parallel right here on this tube. And it actually, what I'm doing is introducing a lot of RF noise. So when I grab this, what's happening is my body is acting as an antenna, and there is a capacitance between my body, between my fingers, and the probably the grids of those two triodes when I grab that like that. Now what I can do to stop that is touch any part of the chassis. So now there, you know, anything that's going into my body, any stray RF that's in the air, is going directly to the chassis, to ground, instead of being fed into those triodes. Get this down here where you can hear. You ready? All right, there's me grabbing it. See, so this is RF interference. No RF. I'm a big antenna. Now I'm not an antenna. See there? I think that replacing it with a 50 microfarad is probably the choice that will yield us closest to the factory, because I believe that the other technician who was in here before replaced pretty much everything like for like, with the exception of rewiring these first two sockets for different tubes. Okay, so there's that capacitor changed, and let's fire it back up and see if that gives us anything even resembling a lot of noise. I think that's probably going to be just fine. Nobody's going to be sitting in the back of the amp grabbing this thing anyway. But I have a feeling that's probably why Leo Fender, you know, changed the design of the amp pretty early on, was because he just kind of realized that that 6J5 was enough, and it probably quieted things down somewhat and gave him less distortion for one, and it wasn't as rowdy of an amp. But you know, in today's age, it's interesting to have the amp in its original form, and we like rowdy amps now, so that doesn't really faze us. Yeah, there's still a lot of noise, but you know what? I can kind of attribute that to the fact that there's no center tap on the 6-volt winding, for one. Plus, look, there's no shielding. We've got all these lights up here. There's no shielding on the inputs at all. We're just exposed, so that's a lot of it. But also, I think there's I think this tube is kind of bad. I think this one is kind of bad, so I'm going to switch it out. I think this tube is bad, or it's a lot noisier for sure, because we were getting noise before. So let's move this tube to that position. Let's move this one to the phase inverter. And let's try this other channel again. I think that will tell me whether or not. Yeah, that's a lot less noisy. I think it would be even less noisy still if I were to get a different tube for this position. Okay, so if we look at a pinout for a 6L6 tube, we will see here that this applies to the 6L6G, which is the big Coke bottle, the GA, which is a smaller glass encased tube, and some of the other tubes also within that family, 5881s, which is another tube that could be used in this amp. The 6L6, if we look down here, just the regular 6L6, okay, if we look at this, the 6L6, the pin 1 is a shield. A 6L6 is a metal encased tube. So that was the early version of the 6L6 that was just metal encased. And with that setup, that would make a lot of sense, because then you would have all your tubes with built-in shields if they were all metal. And that's probably what this amp had in it when it was made, and it was built for those type of tubes. And I'll show you what I mean. Each one of these, now as we've already seen, each one of these sockets has two of these tied together to ground. So it has pins, I think, what was it, 8 and 1 on the 6 SCs. And one of these would have been the shield for this tube as well. Now it's a no connection, but it would have been a shield. So you've got one of the sides of the heater tied to the shield and tied also to ground. And this is the return for the heater. So you've got your heaters coming out over here. You can see, all right, here are the two wires for the heater coming out of the transformer. One of them is going to this point, and then it shoots off over to here and then feeds the rest of the tubes. So this one goes to this point, and then it splits off of that, goes on down the line. And you can see all those. You can see all these right here. It splits off, goes down here. And the return is through the chassis. So the whole chassis is the heater return. And the problem with doing that is if you move to all these tubes that don't have the shields built into them, then you're just introducing a shit ton of noise into the system. And this is just not a good way to do this. So what we're going to have to do is rewire these filaments. And now, obviously that's going to take away, again, from the originality of the amp, but it has to be done because at the time, again, this was made, you would have had 6L6s in metal cases, and you would have had all of these SCs, these SC7s, they would have all been metal as well. So they would have had their built-in shields, but you just don't have that. So, returning the heater through the chassis like you're doing and then tying the other end, see, this is the other heater return right here, and it's just going directly to the chassis. And what we need to do instead is take this and tie it over here to the heater of this tube, and then wire these tubes and wind these filament supplies all the way down. That's the only way we're going to get rid of the noise. And then we'll put a virtual center tap over here to ground, and that should quiet this thing way down. And the reason it wasn't necessary at the time that it was designed, once again, was because all these tubes would have been metal, whereas now they're all glass and they have no shielding. So yeah, let's go ahead and fix that. That's going to make this a better amp. And it's not really a modification. It's only a modification in terms of allowing you to use more tubes than you would have at the time that this was built. Okay, so now we have the filaments rewired. As you can see here, I clipped off where these two were tied together, so I just basically was able to clip this one. These are the heaters, number 7 and 8. This is pin 1, which is the shield, and that was the same on all these because these are all 6 SCs on the preamp. But you can see out here I've twisted the filament wires and have rewired all the filaments, so none of them are tied to ground yet. We're going to create a virtual center tap down here on this end. And what I'm probably going to do is actually virtual center tap this, but I'm going to center tap it to an elevated point. Probably to the cathode of the one of these output tubes, and that's going to further reduce noise, hopefully. Fingers crossed. You never really know exactly how much good it's going to do until you do it, but I have a sneaking suspicion that this is going to greatly reduce the noise now in this amplifier. Okay, so there we go. I've got a virtual center tap installed. And what you can see here is I've got 100 ohm resistors going from each side. So this is one side of the heater filaments, and I've got a 100 ohm resistor going to the cathodes. Now these cathodes are tied together on the output, and there's a single bias for both. So I've got one side going to the cathode, and I've got the other side of the heaters also going to the cathode. So we're going to fire this thing up and see what it sounds like now. I'm crossing my fingers. I'm pretty certain that this will help, if nothing else. I mean, it shouldn't make it worse. And if for whatever reason if we find that the noise is still unacceptable, what we might do is, instead of going to the cathode, we may just go over to ground with those two resistors. So check the voltages as we dial it up again this time. I don't hear any hum yet, so that could be a bad sign or a good sign in this situation. We seem to be drawing a little bit more power now, though, for some reason. We're up to that might actually be throwing off the bias on these tubes, because we're up to 110 watts of power. So it's possible that tying them to the cathode like that is throwing off the bias and driving up the overall wattage of the amp. And I think that probably is the case. So probably what we need to do is go ahead and tie these to ground instead of elevating them. Oh, that is worlds better. Not nearly as much hum now. So I think let's go ahead and move those to ground instead of having them tied to that cathode, because once again, like I said, we're throwing off. We can see our reading up here. About 110 watts of power we're drawing, and 1 amp of current. So that's telling me that this thing is probably over biased at this point. It definitely is over biased from where it was before. It was at drawing about 80 watts or so, and that's probably about right for a couple of 6L6s. For an amp, of this size and type. So yeah, let's go ahead and change that so we can get our bias back under control. Okay, let's try this again. I have moved the virtual center tap to ground instead of to the cathode of the 6L6s, and I think that's going to solve that bias problem. But let's monitor the first node again over here. What was it before? 300? Was it 330 or 350? I can't remember what the voltage was. And like I said, I think before it was in the 80 watts range. And it was definitely, under an amp. Now, we had gotten this up to 110 watts, and then this was just over an amp a moment ago when we tried, tying that virtual center tap to the cathode. Listen to that. You hear that? Bam. That's how much noise my soldering iron is introducing. There's still quite a bit of noise there. It's not, I think it's better than what it was, but definitely seems like it could still be improved. I'm going to check the grounds in this just to make sure all the grounds seem secure and all that good stuff. But, it is quiet when turned down. But see, I mean, a lot of the noise is definitely being introduced by these tubes not being shielded at all. So, I mean, that doesn't help. Okay, so we have our virtual center tap tied to ground. We are measuring our plate voltage here using our bias probe. I've got a bias probe hooked up. And if you want to make one of these bias probes for yourself, I show you how to do that in another video. You can click up here and I'll show you how to make one of these for around $3 to $5. Really cheap, really, you know, it's an easy way to go. And you can even upgrade it slightly and make the bass even a little bit better than I did in that video for under $10. So definitely worth checking out if you want to make one of these bias probes yourself. But really the way to do this, the reason that you make one of these is so that you can access the plate voltage by measuring external to the amplifier. So if this was still in the amp and you didn't have this open, you would still be able to do this by plugging the bias probe in, measuring your plate voltage, also measuring the plate current, which is being displayed down here. And I don't know if you're going to be able to see it or not, but you got to be careful. Don't touch the leads there. You'll get quite the shock. You can see there 43.6 is the plate current. So what you want to do to calculate the plate dissipation for one of the tubes is to multiply 343, which is our plate voltage over here, times 0.0436. That's because this is being measured in milliamps. So 43.6 is the milliamps. So this would be converted into amps. If we calculate that, you'll see it's about 15 watts of plate dissipation. If we check the RCA tube manual for 6L6s, the plate dissipation for a 6L6 GC tube is 30 watts. If we take 70% of that, and we should come up with something in the region of 21 watts, but as you can see right now, we're only at 15. Now, if we'll recall, this thing originally would have had 6L6 tubes in it, not the GC. So it originally would have been these tubes, which would have been the metal encased 6L6s, which would have dissipated 19 watts instead of the 30 that these GCs are capable of dissipating. Okay, so I think I found part of the reason why this thing is so noisy. I didn't notice this before, but the input jacks, I was cleaning them just now, and they're not grounded. You see right here, this has two terminals. So when you put a guitar cable in here, or phone plug, whatever you want to call it, it will move these two pieces apart from one another. You see there how this piece of metal is being moved downward, and it's being moved away from that second piece right there. That ungrounds it. So that second piece right there, that's coming up to this terminal, and that should be forever tied to the ground, and right now it is not. The only thing really grounded is the is this terminal. I think all of these input jacks may have been either replaced at one point, or at least the wiring from these input jacks have been replaced. And this is wrong. So the jacks themselves should not be grounded in this manner. But at the very least, I need to add a wire from here to jumper those two and jumper these two. So that way, when you are playing through one of the channels, the other channel's not just sitting there on. It's completely grounded out. Okay, so I figured out exactly why this thing was so noisy. If you look at these inputs, you'll see only two of these are grounded jacks. This is a grounded jack right here, and this one is a grounded jack, but this one's not grounded. There's no third element there, and this one's also not grounded. When I was testing this thing out, for whatever reason, I was plugging into the grounded jacks only. I was plugging into this one to test this channel. I was plugging into this one to test this channel. But the thing is, there are actually 4 channels on this amp. If we look at the schematic, you'll see each of these inputs is supposed to be grounded. So this input's supposed to be grounded jack. This one is supposed to be a grounded jack. This one is too, and this one is too. And each one of these goes into a separate triode on its 6SC7. So this goes into a triode, this one, this one, this, and this one. So if you leave this amp where you've got no grounded jack here and you plug into this one, for instance, you are letting a shit ton of just noise come through the amplifier. So there, even if you turn the other channel down, you're turning this section down, but you still are going to have this triode, which is just producing nothing but noise feeding through. So that is the reason that this thing was so damn noisy. So I tested it by plugging into this jack, for instance, and this one is grounded, of course, and this one's grounded also. And then I took a wire from here on this one to ground. So to ground that. So now all of the jacks not in use are grounded jacks, and it's dead quiet. So that was the problem all along. It's time to pretty much give this thing a test after I get those jacks in. Okay, so finally, finishing touches are on this amplifier. I did rewire the inputs, and I've got a couple of new input jacks in here, as you can see, this one and this one, and I've wired these together in such a way that the grounds are connecting between the jacks, and so that keeps them also from moving around independently. They're a lot more stable that way when you solder the two together. So we've got all the grounds also soldered together on both of those, so that should be good for that. And yeah, man, this thing is really dead quiet now with those jacks sorted, and with the filament wires all sorted so that they're not going return through the chassis on individual tubes like they were. Yeah, I think just a lot better. And then we've got the virtual center tap over here that we installed. So those are really the only modifications to the amp that we did, and those I wouldn't consider modifications, because they're not going to change the tone, really. They're just going to quiet the amp down and make it a little more suitable for 21st century play. So yeah, this thing is ready to go. I also installed a couple of Coke Bottle 6L6Gs from the 1950s. A lot more suitable, a lot more apropos for this amp. So I think we are ready to get it back in the cabinet and give it a test. So this thing is now dead quiet. Now obviously I've got a Telecaster single coil pickups, and I'm sitting right next to the thing, so when I turn up, you're gonna get some buzzing, but I mean, this thing is really quiet. Dead quiet, in fact.